Alright, so here I want to take this question as an example to show you how to solve relatively complex questions involving the time and money. So this is question number 8 in homework 5. So let me first read the setup. You would like to have $33,000 in 12 years. To accumulate this amount, you plan to deposit each year an equal sum in the bank. So before I continue, I just want to say that this already suggests it's an annuity problem because it says deposit each year an equal sum in the bank. So which will earn 7% interest compounded annually. Your first payment will be made at the end of the year. So the last sentence tells us it's ordinary annuity rather than annuity due. Because annuity due, the first payment starts immediately, right, at the beginning of the year. But here the first payment starts at the end of the year. So part A, how much must you deposit annually to accumulate this amount? So this is a relatively straightforward question. It's just solving for the annual payment, given the we know the this $33,000 because you would like to have this in 12 years, though. So this $33,000 is the future value, and you also know the interest rate is 7%. So, and you know it's gonna be 12 payments, right? You would like to have in 12 years, and you start from the end of the year. So you plan to deposit each year an equal sum. So that means you will have 12 payments. So this is a pretty standard question given the future value and the interest rate and the n. So let me write down this in my OneNote to further show you what's going on here. So for any time and money question, I would suggest you to draw a chart. So let me draw a chart here so that we can better understand what's going on. So this is gonna be somewhat long because we have 12 years, and each interval here stands for 1 year. So let me count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so final 12. So the problem is that you want to have $33,000 here, and you want to deposit an equal sum each year. So this is our payment, and the setup also tells you the interest rate. That's the I is 7%, and N, that's the number of payments, equals 12. And obviously this $33,000, that's the future value, 33,000. So now, given the formula for the future value of annuity, ordinary annuity, future value of an ordinary annuity equals payment times 1 plus interest rate raised to the power of n. Because we are calculating the future value, so this is positive, the power is positive, minus 1 divided, everything divided by the interest rate. So this is the formula for the future value of an ordinary annuity. So now just plug in the number. Now we need to solve out this payment. So 33,000 equals payment times 1 plus the interest rate 7% raised to the power of 12 minus 1 and then divided by 7% interest rate. So now we can I can solve this by dividing both sides. So let me use another color pen. Both sides by this whole chunk. By the way, this is called the future value interest factor of annuity at interest rate 7% and for 12 payments. So that's the name for this whole chunk, future value interest factor of annuity. So dividing that, dividing both sides by this this whole chunk, we can solve out the payment. So let me do this calculation in my calculator here. This whole chunk, we can pull out my calculator. So this is gonna be 1.07%. 1.07 raised to the power of 12 equals, so this is the 1 plus 7% raised to the power of 12, that equals 2.25219, and then minus 1, and then this equals my numerator, and then divided by 7%, 0.07. That's my denominator. So now this 17.888, that's my final number. But I would like to keep this number this way because later on, if I run it, it might affect my final answer. So let me just keep this way. So even though I write this in my scratch paper, I still have to keep a certain number of decimal places, but in my calculator, I just keep all the whole numbers, So this is again, this equals to 17.888. So let me here keep 4 decimal places. So that's gonna be give me 8885. So again, this is just in the convenience of writing on this pad, but when I actually do the calculation, I keep all these numbers. So what I do is now I divide both sides by this 17.8885. So that will give me this final payment, annuity payment, divided by 17.8885. So as I said, if I do this way, then that's gonna lose some of the decimal places. So what I do in my calculator is I actually divide this by 33,000, and that equals, obviously that's a very small number because actually I'm doing the inverse of what I need, and then once I have the inverse, I just inverse it back. So what I do is normally this should have a, yes, and I believe any scientific calculator should have a button with 1 over x. So that's basically doing the inverse of a certain number. So let me do the inverse for this number. So that will give me the final answer. So it's 18,144.77. So now let me plug this number into back to my Math and Snap to see whether we got the right answer, 1844. So then check my answer. Yes, we're done. So let's continue. Part B, if you decide to make a large lump sum deposit today instead of the annual deposits, how large should this lump sum deposit be? Assume you can earn 7% on this deposit. So for part B, the change relative to part A is instead of making the annual deposits, now we are making just a one single deposit today. So that's make the calculation even simpler because now we know the future value, interest rate, the number of years, and then we're trying to figure out this deposit today. So that's my present value. Okay, so now I need the formula for the future value of a single cash flow. Right, future value equals now present value times 1 plus interest rate raised to the power of n. So the future value, the interest rate, and n is the same as before. So the only thing changes is the unknown. So then we just plug in the numbers. $33,000 equals this unknown present value times 1 plus interest rate raised to the power of 12. So now I need to divide both sides by this chunk. So again, let me use a different color pen to show you more clearly. This chunk. And this is called the future value interest factor without the annuity, right? It's the future value interest factor. So let me divide both sides by this chunk. So then just pull these numbers back to my finance app and see whether we got the right answer. It's 14,652.39. Okay, check my answer again. Yes, good job. So the final part C actually is the most difficult part. And then I have to go through the first two parts to get you there. So let me here read it out. At the end of 4 years, you will receive $11,000 and deposit this in the bank toward your goal of $33,000 at the end of 12 years. In addition to this deposit, how much must you deposit in equal annual deposits to reach your goal? Again, assume that you can earn 7% on this deposit. So the part C is a sort of a combination of the scenarios in part A and B. And similar to part B, you will have one single payment. And this actually is given, $11,000. And also similar to part A, you will continue to deposit annual sum, annual cash flow to your account. And your goal is still to reach to get $33,000 by the end of 12 years. So it's that's why it's said it's complex, and it means it's a combination of different scenarios, and that's why sometimes it makes the calculation a little bit more involved. But given the understanding we gathered from part A and part B, solving this question actually is not that challenging, especially with the help of this chart. So let me just put down what happened in this chart. Just use let me use a blue pen to denote this additional cash flow, which occurs in year 4. So this amount is $11,000. So let me double check I got it right. Yes, by the end of the 4 years we receive this amount. And your goal is still this. Now we still need to get this uh, get this annual payment. That's our goal, right? It's still the same as part A. We're trying to solve out this chunk, this payment. But now the additional twist compared with part A is we have this single payment by the end of the year 4, $11,000. But remember, first, you cannot directly subtract this $11,000 from your end goal of $33,000 because given the concept of the time value of money, these two cash flows have different, they occur in different time periods. So that means you cannot directly operate on these two cash flows. You cannot add them up, and also you cannot subtract one from another. What you can do in order to do that, in order to operate on these two cash flows, is you can convert this year 4 cash flow to the same time to this end goal. So you can convert this year 4 $11,000 to year 12 cash flow. So that's my that's how we can operate on these two cash flows. So what's going on here is think about this scenario. You have given, if you stand here you at year 0 and you expect to receive this amount, $11,000 by the end of the 4th year, but your goal is still $33,000. So when you receive this $11,000, you will keep this amount in your bank. So starting from year 4, for this $11,000, you will also receive payment, interest on this deposit, on this saving. Right? Every year you're gonna still receive a certain amount of interest, and this is gonna continue compound for how many years? So because you start from year 4 and continues for until year 12, so that's gonna be for 8 years, right? 12 minus 4, that's gonna be 8 years. So you will compound this $11,000 for 8 more years before you make them to be on the same time point as your end goal. So then I think the very logically we would be first step we would be getting the future value of this year 4 payment, right? This year 4 lump sum cash flow, $11,000. We try to get the future value in terms of year 12 first, because that's how much we're going to have in our bank account for this amount. And then because our goal is $33,000, and we know that how much we're going to have with this amount by the end of the 12th year. So, and then our net goal, so the net goal is simply this $33,000 minus the future value of this $11,000. And then our annual payment, the purpose of the annual payment is simply to reach this net goal. Net goal will equal to $33,000 minus whatever future value of this $11,000. But remember, this future value is in terms of between the year 4 and year 12. So that's gonna be for 8, for not for 12. So you see the difference between the year number and the number of years in your formula for in terms of the future value. So here the future, the n, that's the n should equal to 8, should be equal to 8 rather than 12. So that's the twist. And then other than that, everything is still the same as part A. So so now let me do this calculation. in my OneNote. So based on what I said, we can do this in 2 steps. Right? Step 1 is to figure out net goal. Net goal, as we said, that equals the $33,000 minus the future value, and future value for compounded for 8 years of this $11,000, which you expect to receive. So let me write down this more clearly. You expect to receive by year 4. So then we can do this calculation first. So this will be net goal will be $33,000 minus $11,000 times the future value formula, 1 plus the interest rate, 7%. And then again, the power here should be 12, not 12, sorry, it's 8, right? Because you only have 8 years between your the year you receive this payment, year 4, and your future date, year 12. So now let's figure out this future value first. Okay, just to save some time, I did this calculation in my calculator already. So the final answer for this net goal is 14,099.95. So this can be done pretty straightforward. So that's our step 1 to figure out net goal. So then step 2 is, given this net goal, now this net goal becomes the new future value for our 12-year annuity, right? Because that's the purpose of making the annual deposit, is to reach this net goal. And this net goal occurs in your year 12, so that's our future value. So then the difference between the second step and part A is the difference between the future value. Now the new future value is this net goal instead of this original $33,000. So now the future value, given that future value, let me just write down, this has to be new, that equals to the net goal. And this equals the future value of annuity. And given the formula, this equals payment times 1 plus interest rate raised to the power of n minus 1, and everything divided by the interest rate. So now just plug in the new numbers. This is the new future value. So just plug in that number, 14,099.95. This equals payment times 1 plus 7%. Now this power is still 12 because we're going to make 12 payments. So the power here equals the number of payments minus 1 divided by the interest rate. So again, this payment is simply, to solve out this payment, we just need to divide both sides by this chunk, which is what we call the interest future value interest factor of annuity at the interest rate 7% for n payments, or for 12 payments. So again, I'm going to use the same trick which I did for part A and B, and solve out and do this chunk calculation first. So again, if you still recall, the number we got is 17.8 8885. Again, it's just for the purpose of writing down this number. But when I actually do my calculation, I use all these decimal places rather than just keeping 4 decimal places. So the final answer will be 788.22. So that's the new annual payment, 788.22. So now let me put this number back to my MyFinance app and see whether I got the right answer, 788.22. Check my answer. Yes, we're done. Okay. I hope that by using this question number 8 in homework 5 as an example, I have helped you to better understand how to solve the questions, relatively complex questions involving the time and money. So you see that the trick here is to first, you cannot, as I said, repeatedly said, you cannot subtract or add the cash flows which occur in different time periods. But what you can do is to convert some of the cash flows to the same date as some other cash flows. Then you can do the subtraction or the addition, and then you can get the sum of the net amount for what you need. And then based on that amount, you can do the calculation. So that's the trick. So always think about the cash flows. They need to be on the same date, and that's the essence of the concept of the time value of money. Alright, so I hope that this recording can help you to better master the skills of solving the time and money questions. And that's it for the discussion for this question.